All right. I know it's crazy right now. It's Wednesday. My hair. I'm just trying to. All right. I have not been sleeping all day. That's what it looks like. All right. Anyways. Yeah. Oh my gosh. It's Wednesday evening. It's crazy. It's been a crazy, absolutely crazy week. Homeschooling the boys, basically. It's different. It's very, very different. So, Algebra 2 people, here's our first lesson in a while. We're going to do rational exponents. So yeah, I mean, there's so much to talk about, but there's just, I'm going to just stick to the math tonight. Maybe another night, I'll tell you about how crazy things have been around here, but I'm sure things have been crazy around your place. So we'll save the craziness. We'll put that aside. And we'll just focus on the math. So rational exponents is our topic in our next category of mathematics. And it's kind of a simple procedure, actually. For example, let's say that I have the square root of 8, but I want to change it up a little bit. I'm going to change it up. Well, you know what? No. Let's do it old geometry style. What would we do with the square root of 8? Well, we would say that the square root of 8 equals the square root of 4 times 2. And then what we could do is we could take the square root of 4, because I know that inside 4 is a pair of 2's. So I've got 2. Square root of 4 is 2. And then what's left is 2. So I leave it inside the radical. And the radical is just this symbol right here. So 2 radical 2, if you entered that into your calculator, it equals the square root of 8. It's the same thing. They're equivalent. But let's say, though, that I have the square root of, say, you know what? Actually, let's take the third root. Okay, the third root means the cube root. All right, now the cube root of 8 is actually, well, let's see. I'm looking for 3 or triples of factors of 8. So I can say that 8 is 2 times 2 times 2 times 2. So if I want to take the third root, I can say, well, the third root means that, well, what times itself 3 times equals 8? And that's 2. In other words, I'm taking out a triple outside of the radical, and that result is, well, I'm taking all 3 out, and so therefore I have 2. But let's get this a little bit more complicated. Let's say that I'm going to square 8, and I want triples. Well, that's kind of strange, because what's happening is that I want the third root of 8 times 8, and it's not so easy, right? I want triples of 8 times 8, which is also I've got 2 sets of triples, 1 and 2. All right, so if I took out 1 triple, that would be 2. All right, and then if I took out the other triple, that also would be 2. So I'd have 2 times 2, and that's 4. So what I'm saying is that this right here, the third root or the cube root of 8 squared is actually 4. What if there's an easier way to do this? What if I said that there's another way to write this as a rational exponent? Oh, right. Let's say that I can rewrite this into a rational exponent so that this grossly simplifies this process. Like, this is way too long. Okay, I'm already at the almost 5-minute mark, and I haven't even touched something so simple. The idea is that I can take this and actually say that I want 8 squared, but I want to take the third root. So I will actually turn it into a fractional exponent, a rational exponent. The rational exponent means that I can grossly simplify the process of what's happening. I don't have to say, like, I'm taking the third root of something squared. I can look at it right here. I don't need the symbol anymore. Okay? So what this means is that I can actually, first of all, always focus on taking that third root, what triple is inside 8, triple factor, identical factor, which is 2. Okay, so now I have a 2. I took the third root of 8. Now I'm going to square it, and that's 4. So 4 and 4. So again, this root right here, what this represents is a root in this exponent represents the power. So what I'm saying is that 8 to the 2/3 means that I took the third root and then raised it to the second power. Okay? So let's try that again. Let's say that I have, I'm trying to go around my mic here. Let's say that I have this. (27) to the 4th power, taking the cube root. Okay, well, let's stand back for a second. I'm raising it to the 4th power, but I am taking the third root. It's the same thing. These two are identical representations. So what we do then is we focus on the root. Let's shrink 27 to its lowest root, and then we'll raise it to the power. Okay? It's a lot easier than going the other way around. If I went 27 to the 4th power, which is 27 times 27 times 27 times 27, then I take out all the triples. That would take forever. Let's do it the other way around. Let's shrink this so that 27 to the 1/3, or I should say take the cube root of 27, then we'll raise it to the 4th power. So 27 to the 3rd power, I'm sorry, the cube root, or the third root, is 3. Because 3 times 3 times 3 is 27. So if I took the third root of 27, that would be 3. That's a triple. And then I will raise 3 to the 4th power, which is 3 times 3 times 3 times 3, which is 81. So one of the things that you're going to have to do on the SAT is being able to go from here in a non-calculator portion, figure out that I am not going to multiply 27 4 times. No, I'm going to represent it as a fractional exponent, take the cube root of 27, then shrink that number down, raise it to the 4th power. That's how you want to approach this. So again, we take the root first, then raise it to the power, which is the same way as writing this. Okay, so I'm going to keep going. What are we at? 8. Okay, I'm going to go about 2 more minutes here. Let's see, we got this. Okay. The square root of 16 to the 3rd power. Okay. Now, what I want to do is I actually want to rewrite this as 16, yes, to the 3rd power, but because I'm taking the square root, I will write it as a fractional or a rational exponent. Now I'll rewrite it like this. It's equivalent, same thing. But what I'll do if I want a number though, I will take the square root first. This piece right here. I'm going to take that square root, okay? Don't worry about the 3 right now. Don't worry about that. Just take the square root of 16 first. That's easy. The square root of 16 is 4. But you still have that 3rd power. So we're going to raise 4 to the 3rd power. Now that's 4 times 4 times 4, which is 16 times 4, which is actually 64. Okay, now you hopefully could have done that in your head, fine. If not, multiply it out. If it was a non-calculator portion, you would have to, know how to do that. But that's essentially the gist of converting this to a rational exponent. One last one. Okay. How about we have you have 125 to the third power. That is the same as saying, well, I'm not raising 125 to any power other than 1, right? It's itself. So that's the same as this. I'm saying that if I take the third power of or third root of something, third root? No. Am I saying that right? If I'm taking, the third root. The third root of something represents this. 125 to the 1/3 is like saying, well, how many triples of 125 can I raise to the first power? All right? So I know that 5 times 5 times 5 is actually 125. That's it. So we're so used to writing this stuff, right? We're so used to writing the square root of things that what we not want to do in Algebra 2 is think of it like 16 to the 1/2. That's a square root. 25 is 25 to the 1/2. We know what these numbers are, but we want to now look at a root or a square root, a cube root, a fourth root. We want to look at that as a fractional exponent. So the square root of 16 is the same as saying 16 to the 1/2. The square root of 25 is the same thing as saying 25 to the 1/2 power. Okay, the square root of 9 is the same as saying 9 to the 1/2 power. And finally 64, or the square root of 64, is like saying 64 to the 1/2 power. Now, just to kind of give you an idea of what that, like how that works, let's think, I don't know. I mean, let's say 9 to the 1/2, right? Okay. Okay. 9 to the 0 power is 1. 9 to the 1 is 9. 9 to the second is 81. This is not to scale, right? This is exponential. But if I were to take the half root of 9, 9 to the 1/2, what we're dealing with is we're going in between 1 and 9, right? Because 9 to the 0 is 1, 9 to the first is 9, 9 to the 1/2 is actually the square root. Okay, it's the square root of 9, so he's going to be in between 1 and 9. Likewise, between 1 and 2 is 1.5, right? 9 to the 3/2, that's 9 to the 1/2. That's in between 9 and 81. I don't know what that number is. It's actually 27, right? Because we took the square root of 9, which is 3. 3 to the third power is 27. So 27 is right there. So exponents don't have to be integer numbers. They can be rational exponents. All right, they can be fractions. And so the whole point of this 15-minute video is to show that the denominator is taking the root and the numerator is raising it to a power. So again, one more time. We'll actually put this up here. Okay. Let's go m to the a over b. Okay. This is the root, and this is the raise. Okay. So you take the root and you raise it to a power. Okay. That's how we handle rational exponents. I'll leave it at that. I've got a maze for you guys to do. And if you have any questions, leave a comment. Seriously, like, leave a comment. It's no big deal. And I know this was, well, kind of a long video, but it's a strange thing. You know, it's an adjustment in your thinking. Perhaps something you're not used to looking as a tag team. Like, you know, when you see something like this, now you're doing two things kind of at the same time. Okay? So that's that. Very important concept. And I just zoomed in. We're going to stop now. Have a good night.